Welcome to our section in this afternoon. And in this afternoon, first, I will continue with some advanced topics. For example, data analysis, and then data visualization, and also how to fine-tune your model. And then we have Say Hi will also introduce how to create synthetic data. So first of all, I would like to remind you to go to our GitHub page and find it here. And what we are going to take a look is the materials. So where you can find a material we need for this afternoon. So for example, the Global AI Content Impact Dataset. So this is the first one you will need to download. So now let's download together. And if you click on it, you can see basically this is the a screenshot of the data set, and you can download it and save it in random place. Okay, I will show you a brief introduction about this. Data set. Okay. So this one, I found it in Kaggle. So it's a website where they collect some open source data. So this data set, it explores the influence of AI-generated content across various industries, including journalism, social media, entertainment, and marketing. So it provides insight into public sentiment, engagement trend, economic impact, and regulatory responses. Okay. So we will use this data set as an example, and for us to conduct some analysis in ChatGPT or any large language model we mentioned earlier, so you can use it to analyze this data because it's open source, so we don't have the security issue. So just pick up one that you feel comfortable with. So you can use AI Studio, so Gemini that we introduced earlier, or you can use Claude, so Claude.ai. So Claude AI we mentioned many times, but we never tried yet. So if you want, you can also try it. You can log on with your Google account, and you have the free plan to use it actually. So you can use the most recent Claude model, which is 3.7 Sonnet, or you can use ChatGPT. So pick up one of the three that you feel comfortable and you already have an account there. Okay. And next, what we are going to do is very simple. We just upload the data set there. So the one that you downloaded, right? So we just drag it. So you drag the data set there. Okay, so you found the data set here. You just drag it here. Okay, so I'll just show you how I conduct this analysis. Now I use Claude, and you give a prompt. And this prompt can be very simple. Please analyze these data sets. Just it. We don't need to have, because at this moment, we just want to have a exploratory analysis, some descriptive analysis. So we don't need to really type it in detail, like give very specific instruction. We'll just let it explore. And then you click enter. Okay. Meanwhile, I will try it with AI Studio and ChatGPT, just to compare. Okay, so let's see. So you can see from the output, right? So the first thing is the overview of the data set. So give you a brief introduction about the information presented in this data set. So it's about AI adoption and impact across different countries. And for Claude, it summarized key insights. So AI adoption trend, industry adoption variation, regional differences, temporal trend, economic impact, and things like that. So you can find everything here. So I want you to read it and share your thought about this. So you can tell me, what do you think about this result? And this is the results by AI Studio. So Gemini 2.5. So you can see the output is much more detailed. So again, because this is a more sophisticated model, so it perform more detailed analysis than the other one. So it give you also some relationship, right? You see, relationship analysis, so correlation analysis. And also some potential limitation and next step. So it also analyze, okay, the data granularity is not very strong, right? And the matrix definition, top AI tool only list one tool, things like that, right? So it just show you some opinion of the model. And this is the one conducted by ChatGPT. So you can see here is the regression. Oh yeah, and I asked it to perform some analysis. You see, also visualize. So you can see it also offers some visualization. So you can see here. Yeah. So first, after when I submit the data set, I say, can you do some exploratory analysis with this data? So it indeed did some very simple analysis. You can see, and then I say, he asked me, would you like me to do visualize trends over time, compare countries or industries on key metrics and check correlation? So I said, yes, please perform obvious analysis. So apart from just show you some descriptive data, it also proposed some additional analysis. So then it visualize, all the possible data. But, sometimes we want it to black and white, right? Because, if you are going to send it to a journal, they sometimes request you to have only black and white color. So I say, can you change the color to black and white? Then it did some moderation of the data. Yeah, so you can take a look and explore a little bit now. So what I want you to do is that you can continue with the chat to perform further analysis. For example, you can say, can you perform some correlation analysis of this variable and this variable? For example, the AI adoption rate and the consumer trust. So we can try to see if it's significant and what is the correlation at this moment. So you can further check it. Okay, so I give you maybe 2 or 3 minutes so you can have time to interact with the data set a little bit. You can try different model. If you use Claude, maybe you can also try other model to see if it is better or worse. Okay, and then the next step is to try to reflect. What is the strength of this analysis? What can we do using this tool, and what is the shortcoming? So you can think about, okay, if I'm going to use it for my journal submission or for my data analysis of my data, what will be the strength and what will be the weakness? And in this case, given the weakness and the strength, in what scenario can we use it? And in what scenario we should avoid using it? So when can we use this? Yeah.
I mean, the weakness is definitely that you don't have transparency. Right?
Yes.
Steps.
Yes.
If you need to report them, that's definitely an issue.
Yes. And maybe even if you ask it to produce maybe T statistics or like F value, P value, you still don't trust it, right? You I'm sure because you don't see the process, so you feel a little bit. And also, I don't think that's a good approach. Sometimes, for journal submission, you need to document the output. You need to submit the output. So maybe that's not a good choice. Yeah. What else? What can be the issue? Or what can be the strength? Yeah.
I did the clustering.
Mhm.
And it actually provide PCA clustering, but without any specification of the dimensions. And then in the outputs of the clusters, it actually mixed things that shouldn't be mixed. High level of GDP. It was like high income countries with the level of trust in AI. So cluster 1 represents high income countries, cluster 2 represents countries with high level of AI, and cluster 3 is high level of AI and job loss, something like that. Things that are not compared.
Yeah.
Comparable.
Yes. So it is not, so they make the choice by themselves, which make us less, autonomous to manipulate the data or to manipulate the analysis. So in this case, we don't have the autonomy to do that. But the strength is that it's very straightforward, and it is good to use it when we are going to just get a first understanding of the data. Sometimes when we want to do machine learning or want to do some modeling, the first thing we need to do is to see the descriptive analysis, right? So in this case, it is a good way to see what is the mean score. Is there some outlier, some strange patterns over there? But again, there's another most severe issue is the security. So the data sometimes is very sensitive, right? If we get data from respondents, we cannot just upload it somewhere, right? So it can be a little bit risky. So we don't know what they are going to do with this data. And so that can be a issue for that.
So if we download financial data from WRDS, compose that, and then upload it again, we pay for that database access, right? A lot of a university pays a lot, so right. So if you don't think you can just share it.
Yes. So the solution, actually, one of the online audience already proposed. We can use them to provide us the code, and then use that code to do the analysis, right? So instead of doing this, we can ask it, for example, as like ChatGPT. Now, can you provide me the Python code? So you need to indicate, okay, you want to have Python code or R code to perform the analysis and visualization. So you need to tell it, okay? And then you click run, okay? And the next step is that we open again, the tool we used yesterday, which is Colab. So you don't need to install it. So it's very easy to use. So you just create a new notebook there. And by default, it is Python. So you use the Python runtime, but you can change runtime type to R. So that's possible. So if you want to use R, because many of us, we feel more comfortable with R because R actually provides more flexibility in terms of visualization, and also R has more package, right? Like Lavaan for structural equation modeling, or process, to do moderated mediation analysis and things like that. So we can actually change it here, change runtime type to R. But here, let's keep it Python. And then we just need to copy the code. Where's the code? Here. Okay. So we just copy the code and then paste it in colab. Okay, so here is all the code. But of course, what we should not forget is to upload the data here. So you need to upload the data here. So again, very simple. You just drag the data to the file section here, and then it should work. And then we click run. It's running. Okay, it finished. So you can see from the output, it really contains a lot of analysis, right? And these analyses are more trustworthy because you know what is the code. And if you're not happy with the code, if you want to do additional analysis, for example, if you're not happy with the independent variable, you want to change the independent variable, it's very simple to do that. So for example, you see here missing value check and unique value categorical column. So it indicates every step that it performed the analysis. Okay. So for example, here you can make some adjustment. For example, if you are not happy with the color, you can always copy that line of code and then replace it with the new one. And it's always a iterative process, go back and forth, and then eventually you will have the visualization you like. For example, here you are not happy with the color, you can always give demand and then ask it to change it. So in this case, you have more flexibility, more autonomy over the data. And eventually you can just copy this output and input together and save it in a document, a markdown or something, and then you can submit to the journal. Yeah.
Yeah, so you're working in Colab here?
Yeah.
So does it automatically connect with Gemini though? Or is
It has Gemini there, but the Gemini here is not very clever. For example, if you add code here, it has start coding or generate with AI. So you can click generate AI and then ask it to, okay, can you write a code to do a cluster analysis of this data set? Okay, cluster analysis. And then you can specify, okay, what is the dependent variable? What is the two variable you want to do the cluster analysis? Maybe GDP or AI adoption and trust, something like that. Okay, and let's see. So you can either do it here or you can use, another Windows, another interface or OpenAI to do the code.
you can also use Colab. You can just run scripts there without using Gemini.
You can also do that, but they are less advanced. The model they use, I think my personal experience is that they are less advanced and they sometimes make a lot of mistakes. For example, let's see if it works, because some issue is error here because they are not very good in writing very complex code. So they tend to commit a lot of errors. See, again, error. So you see there is no df is not defined and things like that. So
Can you please show again, where did you change
runtime.
from runtime?
Yeah, so it's
So
here runtime
Python to, okay.
and then change runtime type. And then you can change to R here. Yeah. And again, here you have hardware accelerator. So you don't need to, at this moment, you don't need to do any change. But if you are going to use large language model or something to do other analysis, for example, the text analytics we did yesterday, then I recommend you to choose GPU. So to have the hardware accelerator of GPU. But here we are just do simple, very simple data analysis. We just use CPU sufficient. Yeah, you see, so it's not good. Say your data set.csv is not found. Yeah, so you can see it's not that clever. It does not understand our context very well. So we need to replace this with our actual name, the actual data name. And let's see if it works. Okay, now again, there is another error. So you see another error. AI adoption rate trust in AI is not found in the dataset. So it does not really read our dataset and then not really, yeah. So you see the limitation of using the integrated AI in Colab. So I would suggest you to still go back to here and then ask it. Like, for example, now I ask it to, can you give me a code to perform cluster analysis. Analysis, and then two variables, AI adoption and trust. And now it gives me a code to perform analysis with that. And let's see if it works. So we go back to our lab interface, and then we can add a code here. So you can add a new code and then copy paste the code we just get, and let's see if it works. Okay, it's performing. Okay, first it do the elbow analysis, which try to find the optimal K, right? So how many clusters we need. So here seems 4, maybe an optimal number of 5, right? And then you can see, okay, if we did 3 or 4 cluster, then you can see 1, 2, 3, 4 cluster with the purple one, the blue one, the green one, and the yellow one. So yellow one represent those unit with high AI adoption rate and low consumer trust. And then the purple one represent those units with high consumer trust and high AI adoption rate. Okay, so you can do this cluster analysis. So again, the integrated AI function is not as good as if we use like OpenAI or AI Studio Gemini 2.5. Any questions so far?
So what you're suggesting is that rather than using colab.
No, we still use Colab to run the code, but then we don't rely on Colab to generate code, because you can actually use it to generate code, but it is not very advanced.
So which one should we use for general?
You can use Claude 3.7, or you can use ChatGPT, or you can use Gemini AI Studio. So 2.5, Gemini 2.5. So they are all very good in producing code. Okay, let me check some online audience. Any question? Okay, no question. So as I assume you all finished this step, right? You all successfully do this. Very good. So next,
I have
yeah.
a question.
Mhm.
And so normally what I've done is that I will use like Gemini or ChatGPT to generate the code and then I do it on R. What would be the difference between doing on R and Claude?
R is even better. Like if you do it locally, then it's safer even, right? But just I here to demonstrate, right? So everybody have the same interface, everybody have the same system, you know, it's easier just for demonstration only. If you are comfortable with using Anaconda, you know, or Jupyter notebook, then just go ahead using that.
I just want to say there is also a limitation on the way the models are trained. GPT-4 is very good inherently on Python. And some systems are very good at R for statistical modeling. So it depends also on the model.
Yeah, very nice. Yeah. Okay, great. And then here we have a small exercise. We can do it now together. So it's really an easy exercise that you can do. So not only when you know, sometimes you don't use R or, you know, GPT, R or Python, you just use SPSS. Does it mean I can still use this kind of tool to help me to visualize? Yeah, and the answer is absolutely. So I will show you. So if you can go back to the GitHub page, okay. So you will find handout. So go to the handout folder. Then you have an exercise visualization. So you can click on it. I will briefly introduce this data set. So it is an assignment that you can submit together. And if you submit this assignment, that means you can get a certificate. Okay. So for online audience, if you want to get a certificate, for example, I know some of you want to get some ECTS, to get some credit, then you can do this exercise and send it to me to my email address. Okay. Maybe let me show you the motivation. This is the certificate. So you will have your name there, me there, and then a fake signature of mine. Okay, and so you can open this this assignment and let's do it together. So the background information is, this is a very simple study, and it's just about showing a dog on your Tinder file. So on your Tinder profile, is it good to show a dog next to you? Okay. And does it increase your attractiveness or reduce your attractiveness? So it's a 2x2 between subject experiment.
I know which one you think.
So you see, you have a male student and a male student holding a dog, the same dog, and a male student wearing the same t-shirt, and then the female student holding a dog. So it is a randomized experiment. And we did conduct this experiment. And so 366 heterosexual participants were randomly assigned to one of the 4 conditions. So we know we need to conduct a two-way ANOVA, right? So normally you need to conduct a two-way ANOVA, and the IV will be the presence of the dog and also the gender. And the DV will be the self-perceived sexual attractiveness. But here we don't need to do the analysis. We just perform the analysis in R, and here is the output. Okay, now you try to find a way. I want you to visualize it. How are you going to visualize it? For example, imagine you already have the output. So this output can be from SPSS, it can from R, from Python. You have the output already. So how are you going to visualize this? So it is a two-way ANOVA, right? So you need to do some visualization. So how are you going to deal with this? So think about it. You can try it out first. So for online audience, you can also try it out and see.
A way for us to copy.
Yeah, you can upload it, copy, paste, everything. Just
It's
think.
PDF, so.
Yeah, it's a PDF, but it can actually. They are large language model are very good at reading PDF, right? Even you can take a screenshot of your SPSS. That's also possible. Where do we have the real data for the analysis, or we stimulate the data? This is real data. So I really did this. So it's a group assignment in one of my class. So we really did this, take a photo and then really conduct this analysis. And these are 2 students and they agree to show them. Yeah. So. Okay, can you tell me the findings? Or have you successfully visualized it? Okay, can you tell me the findings you found from the visualization?
So it says for male profiles, showing a dog seems to boost perceived attractiveness.
Mhm.
The effect for a man was quite remarkable, 0.8 difference. And then female profiles attractiveness is generally higher and shows only a small increase with the dog. 4.1.
Okay, yeah. So that's actually correct. So we can do this analysis together. So you can, the easiest way, you just drag the PDF. You know, the whole PDF, you just drag it there. Okay, just drag it there. Oh yeah, again here, I would suggest you to use when you do this analysis, you open a new prompt. So create a new conversation, because we already performed some analysis before. So to be able to make sure that the model does not confuse, right? So we better create a new chat, and then we check the output there, and then we ask it, could you please create a Python code to visualize the findings from this document. And that's it. This is a very simple but I don't know why it's still uploading. Maybe my internet. I will try with ChatGPT. So similarly, so if you have SPSS output, you can just copy paste your SPSS output there, and then ask it to create a code to visualization. Okay, and it's show you, okay, you need to have matplot library to visualize it, and it show you it create a new, like a data frame of the mean and the SD. You can also ask it to visualize the standard deviation, right? You can have an arrow bar there. So it depends on your preference. Now here is the code. We just copy and go to Colab again. And we can create a new one here, visualization. Since we don't use the original data, we already have the output, so we don't need to upload the data set. We just do it here. Yeah, so it works, right? So that's it. But you can adjust a lot of things. For example, you are not happy with the color, you can ask it to change color. You are not happy with the axis, you can ask it to change it. So it really depends on preference. But that's how we visualize the data. Yeah, so before we always need to use like Excel, and it takes a lot of time, but now it is much easier for us to do this visualization. And according to most journal policy, it is not okay directly to ask it to generate image from like from any large language model and use that image for visualization. You know what I mean? So for example, you download, you ask it to generate an image containing this, and then you use that image from the large language model and upload it to the journal. Like for example, Nature, Science, they are not allowed to do that. But it's perfectly okay if you use it to generate code and use that code to generate image. That's perfectly good. Okay, just for you to understand how to use it in a correct way. Any questions? No. Okay, great. So if you want to submit this assignment, you can just send it to my email address. Okay. And then we will move to our last topic of the advanced topic, which is, I think most of you are very interested in, is to fine-tune a model that you can use. And let's close some windows to make it. So note this morning we talked about RAG, but RAG is more about, okay, if you have a large knowledge base and you want to index or search for certain knowledge, and then RAG can help you to search for that information and then operate that information into the answer. But what about this scenario? Imagine you want to train a model. That model is really good at writing paper targeting to that journal. We know this is a dream, right? So if you are really a person who want to target, for example, peanuts, science, or journal marketing, right? And you know they really have a preference. They need to do this, you know, they always have a guideline, right? And it's very difficult for us to follow, you know, remember all the guideline and then, you know, format our thing, you know, our style to that journal. We want a model that can help us dealing with all this very complex stuff. So in this case, it would be nice if we can train a model who understand very well the journal style and the journal requirement. So in this case, it will be nice for us to generate a data set. And in this data set, there is a lot of question about the journal submission guideline and also the correct answer. And then we use this data set to train a model, to fine-tune a model. Okay, great. So we will start from the beginning. So what we need to do is that we need to download an app, and this app is very easy to install. It's called Easy Dataset. So it is an open source Easy Dataset. So it's an open source package. So it means it's for free. Everybody have the access to it, and you can use it in any purpose. Okay. And here you can download, you know, you can normally if you have an open source package on app, you need to, you know, use install it locally. It's very complex, but they provide a client, which means they provide an opportunity for you to install it using very simple procedure. So you can just click here. If you are a Windows user, click here, setup.exe. If you are a Mac user or a Linux user, you can click the corresponding link. Okay, and then you install it in your local computer. Okay. I'll give you some time to do it. And meanwhile, I will introduce you the document we need, which is again in our GitHub page. So in our GitHub page, Oslo workshop, we have the folder material. And in the folder material, we have the last document we need today, which is submission guidelines, JM. And if you click on it, you find, okay, it is a submission guideline of journal marketing. Okay, so you find it there. It is very, very long about, you know, what you should do, how you should format your document, your manuscript, but it can be even longer because this is just one of the document, but also they have some style guideline which you can.
Excuse me, which of the assets do we need to download? Because there are many. Is it dataset setup 1, 2, 3? That's it.
Let me see. Yes, I think so.
So if you go to GitHub,
so you go, so this
Yeah,
one, Easy Dataset.
Yeah.
And go down, scroll down, there is
indeed.
download client. So
Yeah.
Windows.
Yes, and then it will open several. This is what.
Yeah. It will have several. So select the one which is this one. So for Windows users, select the ESE, the most recent ESE one. This one. And for Apple users, select the DMG one. But you have a different version. You can use this DMG 123 DMG. Okay. I also see a question, I think it's related to it. Can you also do that for Mac? Yes, so Mac is here. Easy dataset 1, 2, 3 DMG. And Windows user is easy dataset setup 1, 2, 3 EXE. Okay. Any questions?
It doesn't allow.
Yeah, you need to, for BI user, you need to first go to your administrator access and then log in there first.
For me, it says it could not be opened because Apple cannot verify if it is free of malware.
And you click continue. No. Because for me it's the same, but I just click continue, right? Here, or you need to set up, you can Google it or ask ChatGPT how should you do. You need to change your setting.
Okay.
Yeah. So for example, when I click here, easy data set, it also say, okay, it is not a. For example, it say installing, please wait.
Still the same.
What did we have to do at the BI?
So you should log on the administrator access.
But still.
It doesn't allow.
Then which of the options? So now I got the.
Yeah, that's good.
But which one?
Sure, already good.
And you just click on. Oh, no, it's not yet the download. Yours is not allowed. You see, it's not allowed to download. Yeah, because it say it is not safe anyway. Yeah. Yeah, so when you download it, you see it. Yeah, now it works.
So it's keep and then keep anyway.
What?
Yeah, I managed.
Yeah, now it works.
Fine. Like a continue option. Would I
There's an administrators on there in the morning.
Yeah, I know.
Have you been doing
I
it?
do.
Yeah, collectively.
You first need to adjust security setting.
Huh?
So you go to here and you follow this.
Get the firewall, yeah.
What did we do there?
You see, like
Nothing, because last time when I tried with my email.
Yeah, now you need to log in
I
with
can't.
your.
It don't- Last time we didn't really.
Yeah, but now if you open the administrator, then it will still work.
Should I just saying cancel or should I allow? Because I will not
You
allow.
last maybe.
Yeah, but then it doesn't.
That doesn't work.
You cannot.
Okay, I can.
Yeah.
It's a different application to run the admin.
You have the admin open the access. Yeah, so you need to first have your access. Yeah, you can cancel. So you go to the admin
What is my?
more. And then BI at this is BI administrative. And just type administrator. Yes. So you need to log. Does it work?
Yes.
Okay, great. So some people works or no? Okay. Okay, so I saw most of you already have the access. Let's see some online questions step by step. Yeah. So there is somebody already shared the bypass security warning. So that's nice. And it is not really a it's an open access software, and it is uploaded in GitHub, and many people use it. So you can see there are lots of fork and save like in GitHub, so it should be safe. Okay, so next what we are going to do is to configure this software.
Right.
So first, what we can do, I will delete everything from the beginning. So what we can do is to create a project. So we can create a project, and this project maybe can be journal of marketing, JM style model, or data set, something like that. Create this project. And you don't need to do anything else, just create a project. And next, it is something tricky, so you need to configure one of these models. So if you have GPT-4o, then you can use your GPT-4o API. So you just need to copy paste your GPT-4o API. And if you have DeepSeek, then you just use DeepSeek. Okay. And sadly, they don't allow other, like for example, they don't have Claude, they don't have Gemini, for example. So you don't have a lot of option. You also have Olama, means that you can also use a local installed model. But here I would like to share you, because some of you probably you don't have GPT-4o, so I would like to share you my own API so you can use it directly. So you can use DeepSeek, my DeepSeek API.
The API on the ChatGPT, where is that stored?
You have it? Yeah, if you want to use OpenAI, then go to OpenAI and then API. And you should be able to find your API there, but you need to pay for it, or maybe they allow you to use it.
Also plus users?
I think maybe they have certain free limit, free credit. You can try, you can definitely try. So you go to this website and then click the setting. So platform.openai.com and then setting. And then you have the API keys, then is where you can save your API key. See, my Mimi talk is here. So you should not share your API key at all to other people. And DeepSeek, I also have API, so I would like to use DeepSeek this moment, so you can, because it's really cheap. Even I use it already a lot, it only cost me 0.02 US dollar. So that's why I'm fine to share it with you. So I will just create a new API key called test. Okay, I copy it and I share it in our GitHub page. So for those of you who do not have an API, now you can go there. I just put it here. So now you should be able to see it in our GitHub page. So it's just a random number before make it clear. Yeah, so just this one, you can copy.
Was OpenAI.
No, this is DeepSeek.
Oh, DeepSeek, okay.
Yeah, so you can go back to your easy data set and go to DeepSeek chat. Maybe not use R1 because R1 is really slow, and now we want to make it quicker. So, but of course R1 is better. The performance is better. But let's now make it just DeepSeek chat, which they use V3. It will be easier, quicker for us. Okay, and then you just keep everything by default. Again, you see the temperature, right? If you want it to be more consistent, then lower it. If you want to be more creative, increase it. But now let's keep it default. Okay, now you should be able to see it, and we can test it. After we already configure this, you can test it to see if it works or not. So we can see, okay, DeepSeek here, and then we can say, hello, are you working? And then we can see if it works or not. If it works, then you will return something for us. It's very slow. Yeah, it's really slow. That's strange. Okay, it is working, but very, very slow. I don't know why. But yeah, just for demonstration purpose, let's see. Now, okay, everybody arrive at this stage.
The API key.
API key is in our GitHub page. So this one, if you open our GitHub page, the first thing you saw, that is the API key, start with SK.
Okay.
So you copy it and paste it there. And meanwhile, I will give you more time to do that, and then I will share the API key in our, yeah, okay. Yeah, that's the API key. I will give you more time to do that. And those who are already there, now you can start to explore. So you can select the file that we asked you to download, the JM paper, right? So the submission guideline JM, and then click basic PDF parsing and upload and process. Okay, now it's processing, okay? And I will leave it there. I will try to fix it.
Here, I mean.
Oh, no, it's
But
not
here,
here.
yeah,
Yeah,
so what
now-
it says is here,
Here and then.
and then. we don't
Oh,
have to- Doesn't hold it in the-
Start building, I think. Maybe. Yeah, you need to first have your organization.
Thank you.
Yes. You go to. Download this one, yeah. Or if you don't want to use this PDF, you can do other thing. You can do your own other things. Okay, just a demonstration. Okay, now after we upload it, you can see this morning we talk about trunks, right? So it is split it into 12 text trunks, and they use this because it's a big document. So they split it into 12 text trunks to be able to better process it. So we can select all the 12 text trunks and then batch generate question. So what this app is going to do is that based on the text it uploaded, it is going to read through all this text and then see where they can create question based on the text. So it try to create question based on what they have there already. For example, in our text, it said publishing fee and open access. Okay, you have the publishing fee, like for example, 200 euro if you want to publish with open access. So based on this text, it will propose a question. What will be the publishing fee for open access? Right. So it raises question based on the output. Okay, based on the current document we have. And then we can click batch generating question. So it's now trying to propose question based on the text you have. Okay, and it takes some time. So again, you can change this document to other document that you want to use.
Now I can hear. Nothing
Yes,
happens. So
great.
don't, so.
You can test whether it works or not. So go to here. And let's see if it works.
When I was doing that, I lost what you were doing.
Yeah, always.
Oh,
No, it doesn't. Yeah, you don't have, you did not pay. So apparently you need to pay for it. So I would suggest you to now use DeepSeek at this moment to try, just to try it. The computer.
Okay.
Why not,
Because this is not moving. So you need to use this. And then you can copy paste the one, yeah, it takes some time to run it. I don't know why it's super slow at this moment. Anyone have some process?
I couldn't upload the file.
No? Did you try the models that does it work? No.
It doesn't.
No. Maybe restart it again? Does it work?
Processing as well.
Processing, right? It's super slow.
There too.
Oh, okay. Yours work. Okay, it seems MacBook is doing better. So now it create the question. So you can select. Oh wait, you are just doing the chunk, right? Okay, you can select all, and then batch generate. So it depends on different models. Some models are very slow. I don't know why it is so slow. But when it's finished, then it will create some question. And then after the question, so for example, we see, no, doesn't have any question yet. After the question, then you can create a data set. Or even if you want to add your own question, for example, here, you can add a question. Okay, what is the style of this journal? Okay, then you can, here it's just to propose question. You don't need to answer it yet, right? So you can create your own question as well, okay? So the logic is that it will first generate question and then generate answer afterwards. So maybe let's just try with one to make it easier. Okay, somebody report might just show no text chunks found.
Yeah.
Maybe try another document. You can try, using your own paper if you have, using your own published paper or anything you have, just to try. Okay, since this takes some time, I will show you once we create the question, the next step is to, it's also some button. You can create a question based on create the answer based on the question. So it will also generate a question. And then together you can merge it together to create a CSV file, or it can be a JSON file. And with that JSON file or CSV file, then you have a lot of option. So for example, for AI Studio, then you can tune a model. So if you go to Google AI model, you can tune a model. And then you can select which model you want. Like for example, here is Gemini 1.5. And then import the document we just have. Okay, import the CSV file you just created. And then you can give a name of it. Like for example, fine tune JM guideline. right? So model. So then you upload the data set we have and then give a name, select the model, and then you can start to tune the model. It takes some time, and afterwards you can use that model for your own purpose.
Why not upload the submission guideline PDF there? Why the data set that we generate with the question and answers?
No, because they only allow a format where that you have question and answer. You always need to have a format question, answer, because it's a training process. They know that, okay, if you ask this question, I need to give this answer. Right. So it's in this way, so they can get familiar with the concept. So if you only use a document, then it's not supervised learning. It is more exploratory learning, which is not possible at this stage. When you fine-tune a model, you always need to have question and answer. Yeah, it's a supervised learning process. Okay. Any questions?
First thing in the variable.
Let's see. Oh no. I will try to restart it again. Because my stack. But yesterday evening I tried and it's going really smooth, but I don't know why now it's so difficult. Okay. Here and then change. So it's not working. Okay, I will try a different file. Okay, I just use a paper, maybe random paper, and then see if it works. Just a random paper. And now instead of using the chat, maybe let me use R1. Maybe it is better. No, no transfer. Okay, let me check my DeepSeek. API key is not valid. It's invalid. Why? So if you found no trans found, that means your API key is not valid. Okay, let me try this one.
Where was the DeepSeek
API
API?
is on our GitHub page. So if you go to GitHub page, the first thing you saw is, so if you go to this one, start with SK. Okay, now it works. So you don't,
Or
no, it's just on the home page. Yeah. So I know if you used the trunk, if you have no trunk found, that means you used the wrong model. So you should select the checked model. So the R1 model doesn't work. Let's see, format should be found like. Yeah, I used PDF yesterday evening and it works really good. But I don't know if you use stock, does it work? Anybody finish or
Not even able to upload a PDF anymore. It's just like,
then try to restart it again?
yeah, I just did. Yeah.
If no, then I will tell you another easier way.
I don't know.
Ah, you have it? You're back now.
It's very difficult, you know? I mean,
Already go to place. Okay, it doesn't work. Okay, so free things are not always very good. This is open source, it's free, but yeah, they don't have somebody to maintain it, right? So if you cannot manage to do that, I will tell you an easiest way, right? Don't use this software at all. You just go to any of the large language model you feel comfortable, like AI Studio. Again, you upload this file that we created, okay, which is material submission guideline JM, okay, and then you upload it there. So you just need to give a prompt. Based on this PDF, create a data set. Create a data set consists of questions and answers. This data set is for fine-tuning a model. Okay, but of course, now they cannot just produce the data set for you. So you can say, okay, you can just give me an output in a table. So instead of producing the data set, it will create a table for you, and you need to copy paste that table into Excel file. Okay. But yeah, of course, you can do it like this, but if you have a lot of document, right? Sometimes we have thousands of documents to train a model, to fine-tune a model, then it is very complex. Then you need to write a Python code to do that. And this easy data set, it is supposed to be that Python code, you know, the integrated Python code for us to process all this together. But apparently it doesn't work. I don't know why. But see here, it also works by just creating a question and answer for you directly here. Right. So you just need to copy paste everything and copy it and paste it in a, let's copy it. And then go to your Excel file and paste it there, and then save it as CSV file, and that's it. That's very stupid way to do that, but it works, right? Then you have it right here. You have it here. Then you can save it as a PDF, a CSV file.
You download the table or
You can download the table if
in
it
CSV?
have the function to download the table. Does it have?
Isn't it? Oh, yeah, sorry.
No, here I cannot do that, but maybe in ChatGPT
Yeah.
it can do that. Yeah, okay. In ChatGPT, apparently you can do that. Then you can download it directly from ChatGPT. But here you need to copy paste. Okay, let's try with ChatGPT. Okay, let's try with ChatGPT, and then you just upload the same file. Okay, now it is running. It's still processing. Okay.
What was the
Okay.
plan again?
Works. Based on this PDF, create a CSV dataset consisting of question and answer. The dataset is for fine-tuning a model. I will copy it in our okay, and apparently you can download it directly from ChatGPT. So you download it. Let's open it to see if
That's right.
it's not a lot, right? It's only several questions. But yeah, what types of article does the Journal of Marketing publish? What is required in the abstract section in the manuscript, right? Because always, if they can understand this, then they will reconstruct our abstract according to the guideline. You can just copy paste your original abstract and ask it to formulate structure to a JM style. So it automatically just understand it. Okay, you don't. If you're going to submit to JM, then you need to follow this. Okay.
Can you say that again?
So because now by having the question and answer, the model knows if you are going to submit to Journal Marketing, then it need to follow this format.
Thank you.
Like in the abstract section, then it need to have, you see, the abstract must be unstructured, no more than 200 words, and concisely state the research purpose, major finding, and conclusion. Then it knows this style. Then if you copy paste your original abstract, then it will be constructed according to the guideline style. Okay, but you can also use a prompt, right? You can also use a prompt too. But just fine-tuning a model for research purpose is more like, okay, you really need to have a model really specialized in this field, and you find it RAG cannot. Maybe it's not reliable because if you have really a lot of information, you're scared that sometimes they cannot index that certain concept or certain information from that large chunk, right? Large number of chunk. Because if you have the experience of using RAG, in most cases, they're good. But if you have really a large knowledge base, sometimes they get lost. They cannot return the one you want. And then fine-tuning will be the last resort, when you really want to have a very specialized model. Okay.
But also at Claude, right, you're like create a project and then add documents to this project, and then you can have, let's say, okay, this is my layout or my format that I need to follow.
Yeah, you can also do that. Yes.
and
Yes.
stuff like this, right? And
Yes.
then he always
Yes.
refers to it.
Yes, that's also possible. Yeah. But this is just an example that if you, for example, if you have, you really want to fine tune a model that understands Chinese medicine, and you, of course, you don't have, you will have 10,000 of question and answer for each herb and the function of this herb. Then in this case, fine tuning will be really a good approach. Or if you want to have a specialized chatbot in animal or in dog breed, right? In this case, fine tuning is also the best if you want to have that specialized model. Okay, great. Okay, so that's it for the advanced topic. And
So what do we do now with this CSV file?
so if you have the CSV file, now you can go to the Google AI Studio and tune a model there, and then you can upload the CSV file, and then you can fine tune that model there, and you can call that model later for your research purpose. Or if you go to the fire, the fire work that we introduced this morning, they also have this function. So here you have fine tuning, right? So you can also fine tune a model. So for AI Studio, you have just a very few options. You can fine tune the 1.5, Gemini 1.5. But in Fireworks AI, then you can have a lot of other options. So you have Llama, you have DeepSeek, you have Q1, so you have a lot of other options. And then you, for example, I select DeepSeek R1, continue, and then the data set. But they only support JSON, so JSON file. Okay, and then you can check. You can easily convert your CSV file to JSON file. Okay, just a single line of Python code, you can do that. Or just, they should have some CSV convert to JSON tool online here. Immediately you have one there. So you can do that. And you can also use OpenAI one. So OpenAI and then fine tuning. It's also a 3-line of code, then you can do it immediately. So if you go to OpenAI, and then here they have an instruction of how to fine tune it, create a fine tune model. It's just a few lines of code, then you can copy, paste, and then you can create that model. Okay, great. So maybe let's take a break of 15 minutes and we will, 15 minutes and we'll come back at 3:05.
Shows your dedication. So, and everyone online, so thank you for coming. My name is Haye. I'm a visiting research fellow here at BI at the Norwegian Business School or Department of Communication. So I want to thank first Shubin for organizing such a productive workshop. What I want to talk today is about synthetic data, but we're going to look at it from a broader perspective. In the sense, we will focus on two aspects. One is the epistemological aspect of synthetic data and the practical or technical dimensions of synthetic data. To give you a little bit context, yesterday and today, partly, you have seen how generative AI, the development of generative AI can actually avoid some of your repetitive tasks. What I want to do today is, in this session, I want you to think a little bit harder. If there are any problems that you cannot solve alone, how can generative AI help you to solve those problems that you're unable to solve yourself? In other words, what I'm asking you to think about is, for example, what are the Nobel Prize winning problems that are not solved yet? that you can solve, that you're unable to solve on your own, but AI can help you to solve. It's up to you whether you want to share your Nobel Prize with AI or not. But this is what I want you to think. So there are two problems that are to achieve this ambitious goal, and that is data scarcity and inaccessibility. And today's main goal is how can synthetic data basically help solve those problems. So what I will do is first, in the first session, I will give you a general direction, both from an epistemic and practical implications of that synthetic data. And in the second part, we will see a practical step-by-step case, which you will be involved. So to begin with, synthetic data, we don't have an agreed definition on what synthetic data is, but the common definition is an artificially generated data that mimics real-world data. So it's not, in other words, this data is not collected data. As we progress, it will be useful to see these distinctions between generated and collected data. Entirely synthetic data is not new. It has a long history going back to the first Monte Carlo models developed by Stanis Ulam and John von Neumann. Both of them are my intellectual heroes. So this is how far. It also goes back to the census data, basically, that work out in the 1980s and 1990s, multiple amputation estimation. These are one of the earliest attempts. In terms of its type, synthetic data can be generated fully from scratch, from models even, and the other is partially synthetic data. Why? The reason why I said, for example, this traditional definition of synthetic data is problematic is basically what it emphasizes artificial generated data that mimics real-world data. Why is it problematic? Because it doesn't show the full potential of synthetic data by itself. Why? One of the problems that I'm working myself together with others is how to solve this, basically, to expand this definition. And if for some of you that are involved in art, I think you know Aristotle's definition of art, which says art imitates nature. At times, it completes what nature cannot. So in the first phase, it says art imitates nature artificially, and also it completes what nature cannot. So what synthetic data does is it imitates real-world data, but also it completes. So the success of generative AI basically depends on the development of synthetic data. All of them are not trained on real-world data, as we will see later on. So how is synthetic data generated, basically? We have two major technical categories. We have a statistical or probabilistic models from earlier version. This is Gaussian or multivariate distribution. And we have also Bayesian models and agent-based simulation. And after the development of machine learning systems, we have generative adversarial networks and variational autoencoders. These are two, and we have recent development with transformers. We will see later on. There are specific generating steps. We will look also later on in practice. But what it requires is specifically what type of data you require, and then you generate the sort of source needed, and according to those specifications, you generate them. Easy way to do is to give simple real-world data, and based on that, you develop or generate that synthetic data. Here is just 2 days before I come here. I generate this using GPT-4, which you will practice also. On my left is real patient data. So the distribution is, there are two problems, basically. The reason why I did this is we have two hard problems to find with synthetic data or data collection are financial data, and the other is healthcare data. So how to basically...
Are we supposed to see this on the screens behind you? Or are you?
Yeah, you can see.
Are you changing the slide or not?
Yeah, I'm changing the slides.
It's not changing. Okay. Behind you. Look up behind you, you'll see it.
Behind you.
Yeah.
Preview of your slides.
Yes, here
Hey.
you
I had missed something.
No.
So
No,
fundamental.
earlier it was moving.
Thank you.
No.
Okay. Oh, this is easy.
So where can I start? Restart.
Oh, go on.
Go on.
It's fine.
Go on.
We were listening to you.
I was listening very intently, actually.
Well, you could say earlier, much earlier. So here is basically, so the real patient data distribution is on my left side, and the other one is on my right side. If you see, this is sort of a mean age of 60 years, which is typical of patient healthcare demographics, and on the right side, on the left side, on the right side is the sort of 6:1. The division is only 11 years, and the other one is 10. So it's pretty close. This is to say, with it depends. If you want to use, for example, to show the limitation of generative AI models, you can look at this and analyze the data. But if you want to, for example, for accuracy purpose, the next prompt can fix this problem. So what it means, go ahead.
Can you explain how, in this particular case, synthetic patient data has been created? I think it's important to.
Yes.
Understand.
What I basically did is I prompted what is the sort of the demography, patient demography in a specific age in healthcare data set. So I took those specifics and I gave to GPT-4. So it produced this one on my left side as a comparative. So you can.
Did you use the same ones as from real patient data or?
From real patient data, yes, exactly. Yeah. So we have also, we can look at how the models themselves are trained. This is the reason why it's helpful to see how the models themselves are trained, is because it relates, when you communicate with a human being, you can understand the human being much better if you know the behavior of the person. So the understanding of machine behavior by itself is important when you do any task to accomplish any task within generative AI or much advanced models. So what I want to see here is, if you look at it's not very much different, the way models are trained using synthetic data and real world data. So if you look number 1 and 2, this predates what is called generative AI supply chain. It predates. So it's humanly created. It means it's collected data. And in collected data, there are all sorts of problems that we will discuss later on. But starting from level 3, data collection and curation, that is the sort of training data whole until the alignment it goes. So what this shows you is synthetic data is basically a sort of the solution. If you here, how does it work? If you look, the first is the example of input text. Yesterday, Shubin was trying to show you, for example, using the orchestra model that we will see, we will explain now more, probably deeper. But what I want to show you is there are 3 levels. Example is the token style is nothing that it has a different meaning in blockchain, in generative AI, but what it means is basically to manage the data sets according to specifications. And you give it the vector embedding with numbers. And tokenization in a simple human form is, if you want to, for example, a symbol of love is a flower. So that is the token of that object as love. So the vector embedding is also related to the system, how actually this is the way we assign it. So for you, this is a general understanding. When generative AI sees, it doesn't see the words. Mostly people confuse. It sees numbers. The same is with text. Pixels yesterday when Christoph responded, what do they say? What do text to image generative AI see? They see pixels. But what they see is when pixel is represented by numbers. So there is computer vision research, whole research. You can look at here in a sort of a simulation of in real time what is happening. We can take Mimi or me as an example. If I say, for example, in the park, I found a friendly / blank space. What will be the closest word? Will I say, for example, in the park, I found a friendly computer, or I found a friendly dog or cat? Which one is the easiest? So the easiest is basically, so probabilistically, what is the next word? This is how it shows you. So it's not a mystery. These are artificial networks, but they operate based on our own neural nets, biological neural networks. So The only difference, if you want a more deeper technical level, is this is a feed-forward system. All of them are feed-forward. Biological neurons they're rippled with feedback loop. So they give a return. So the practical value, the problem with this data is basically, before we go to the practical value, is this is a collected data, as I said earlier. And collected data are extremely expensive. They involve a lot of personal data, but also unhealthy data. I don't know if you remember, some of you, there was a paper titled Garbage In and Garbage Out. How many of you remember? If you read. So the garbage in and the garbage out is basically to show the dataset that is being used to train these models is complicated by a lot of, from, I don't know, pornography, other issues, sensitive information, disinformation. So this is the problem. So what basically synthetic data can help us in practice is to mitigate these problems. You don't need synthetic data. It has its own problem, as we will see later, but it solves this problem. So data inaccessibility and data scarcity. A simple example is healthcare data is not GDPR compliant if you're using patient, but you can make, by synthetic data, you can make it GDPR compliant. And the other advantage is also scalability. You can scale it. It's easy to label this data, reproducible easily also for other issues. Beyond synthetic data, beyond practical use, it has also epistemological value. To start with, the ontological status of, do you understand what I mean by epistemic? So I'm talking directly here about theory of knowledge. So the ontological status of synthetic data is basically, it's not a direct representation of reality. It is based on real-world data that is a copy of that. So it captures patterns, relationships, and causality in real data, but it's by itself is not a real representation. So what this enables you is basically, there are hypothetical scenarios to predict. When you have something, you want to understand a future event, the next pandemic, or as I will show you, even, for example, I'm working on one paper with my colleagues on transgenerational synthetic data. Transgenerational source of ethical, it involves a problem that we don't have, for example, nuclear waste. We don't have a complete data of, for example, what kind of language will survive in the next 300 years. What kind of human beings will be on Earth in the next 300 years. So if you don't have this complete data, what you can do is basically you can use synthetic data to, for example, if you don't know what language will survive, you're not sure whether English, French, or Arabic, or any other language will survive. So the likelihood, you can use synthetic data to measure, to say, for example, warning, you want to write a warning. Here in this area, there is nuclear waste buried. So we don't know this generation in the next 300 years, but you can use synthetic data to solve these scenarios so this is one of the advantages of synthetic data. The other is basically also rare disease. We don't have enough information about the disease, but you can also complete by having those data that you have, you can complete them. Here is a simple example of a paper that I'm working together with my colleagues, but I brought it because it shows a lot about, this is about agent-based modeling, but one of the issue in the natural and human sciences, to some extent also computational natural sciences, but also to some extent in human sciences, there is the issue of predictability. So fundamentally, our current science is divided into two. For those of you who have a background in the sciences, in the natural computational sciences, there is a deterministic, a sort of reductive materialism. We understand any given system is a sum of its parts. So you add up those parts and you have the whole system. In other words, what that means is from just simply the characteristics, the features of the lower parts, you can predict the whole system. And complexity theory, emergence theory reverse that. Emergence theory says, for example, the whole is more than the sum of its parts. It means, what this means is there is an emergent property. So the whole system cannot be understood by simply understanding the characteristics. So how can you understand, for example, a simple complex models that change their linear directions? If you emergent property, you don't have the sort of scenario, phenomena, a next event that will happen. So what you will do is you give a certain interaction. I can show you here. Here is the data for agent-based modeling, 500. Can you see now this? No. Okay, forget it. So what I want to say is, from this 500 agent-based model, the time step, you can follow the time steps and compute that. A simple example here is the visualization is basically based on Mesa, a Python background, but you can use, for example, classical systems like LetLego, Repast, Meson, and for ordinary tasks, not agent-based modeling, but if you want to run synthetic data on ordinary software, you can use even those tools on Excel package. Yeah. So the other issue is related to epistemological value of the synthetic data is we have to always make sure that the synthetic data is current in the sense, for example, internal consistency, as we will see later. For example, a 5-year-old with a college degree. Doesn't make sense. Does it make sense? So this is what we have to correct. If there is any sort of external validity situations, the statistical alignment with external phenomena, also real-world phenomena, and effectiveness of this synthetic data also in downstream AI tasks. One of the major challenges is to avoid bias, but we will see here, if you look at it, both the epistemic and ethical synthetic data are interrelated. In this sense, synthetic data may perpetuate bias or amplify those in real-world data. So this is the challenge. And there is also a transparency issue, that the importance of documenting assumptions and generation methods for those of you, especially who want to use for publication issues. The reason, probably the importance of this session is we're all established researchers. And when we publish something, we're asked to sort of document the process, provide both the epistemological and methodological steps. So this is helpful. And there are other challenges. This is synthetic data may lack full complexity of real-world phenomena. So this is also related to the sort of, we have our current models do not directly represent reality. So this is not a problem of synthetic data per se, but this is a problem of modeling issue. For example, when we take a flight, it's approximation. We trust the flight, it will take us from here to Germany. But all models are, whether physics, mathematical, or computational models, are approximations. So when systems goes wrong, it goes wrong. So you can, a simple example is weather forecast. Tomorrow it will say it will rain, but it turns out to be sun. So why? Because our models are incomplete to represent this. I think the best explanation is, I don't know, how many of you know complexity theory in economics or in any other field? So complexity views systems as nonlinear. As the system transitions from simple to complex, predictive models become less reliable. So they cannot, there is nonlinear interaction. So just to give you a simple summary before we go to the practice, the practical value of synthetic data is basically, it mitigates bias, data scarcity, and inaccessibility. The epistemological value is it expands the scope of knowledge beyond direct observation limit. So what we will see also in the practice is, I want you to focus on a sort of rigorous validation and ethical use and exploring synthetic data for its full potential. If you don't have any question, we can go, but you're free to ask, please.
Sorry, the slide about validating, how
Yeah.
are we validating? You said internal consistency, I missed what the
Yes.
other. So logical coherence, statistical alignment, so.
Yeah. Please feel free to ask.
So basically, I have been reading recently about critiques of this, particularly in high-risk contexts.
Yeah.
You are suggesting that this is a solution, but
Synthetic data?
yeah,
Yes, it has its own limitations, but yes, it's a solution.
because it seems to be also very highly criticized exactly for the reasons for which it is used, right? It is very biasing, creating average of averages, and really propagating biases against minorities and underrepresented
Yes.
population. So it was created to be used, for example, in patients, but the patients that it is supposed to protect, it actually makes even worse or even more marginalized. So how would you reconcile these two things?
I think the advantage of synthetic data is even a double edge in the sense, for example, we can even use synthetic data to solve the problems that you asked right now. But it's not free of, it's much more easier to use that sort of bias that happens because of synthetic data than real world data. It has. The reason is real world data expose individuals. For example, if we take personal information, they expose actually to real, if there is a terrorist attack, there is a danger to life. That synthetic data doesn't have that kind of danger exposure. This is just a simple example. So it has, but it has its limitation. The sort of advantage that I'm emphasizing is it's actually on a sort of, it's much better than real world data, but also it is reproducible easily. We can use it to actually to solve problems that we don't have a direct observation, but also incomplete data of events that manifest in the world that we inhabit. It doesn't make sense.
It does, but it's actually, so how would you produce? Let me give you an example, because I think you were asking about validation. So you validate what somebody thinks by looking into what other people are thinking about that. But we see that all of the data, or currently all of the GenAI, is created on 10% of people in the world. And then you are saying synthetic data can actually give us information about those who are not in the sample. Those who are not in the sample have completely different cultural, all of the other characteristics that do not correspond to that 10% of the world. So by creating synthetic data, you actually propagate the same problem. How can you synthetically represent something that you do not know anything about?
I understand you. But I think one of the issue is also to understand how the models themselves are trained, including ChatGPT. So we have incomplete representation of cultural backgrounds or linguistic. I'm working myself on such kind of articles, but most of them are actually completed by using synthetic data. We wouldn't have an advanced generative AI ChatGPT by itself, because we were able to complete them with synthetic data, and we have an advanced system now. If I use let's take copyright issue. If I was to train GPT-4 or GPT, the first GPT version, on a copyright, out of copyright materials before 1928, anything is out of copyright. So we can use those materials to train any model. The problem with this approach is it doesn't relate to our context. The context of 1928, pre-1928, the world, what is important for the society, what is important, the information flow is entirely different than for ours. So the reason it's important for some people, for example, I am one of the people who go against these big companies for misusing data. But I think we have also a problem. We would stifle innovation if we don't allow ourselves some of the data to be freely accessible. So the reason why these, let's say, big companies are going illegally, some of them scrapping data, is because most of the data we have is a closed system. It's not open source. So you need, and the only choice is to scrap it, you train the model, and to give, at least as, if you know, I don't know, OpenAI has a moderation endpoint. For example, this is something, a system that prevents racist or sexist prompts that enter, and it prevents you technically. But for example, there are other techniques through which you can break the system, jailbreaks, prompt engineering. Why does this show? This shows you the problem is not on the AI system, but it's human behavior. So when we do research, like any other forms of technology, but we can't avoid, the reason why we're gathered here together is to use or harness the kind of product of GPT-4 or any other model that generative AI brought. So we are using on to our advantage because we allowed some of our data being used for training. Any question?
Yeah, no, maybe just add a small comment. So, and also there are many studies now coming out about the effectiveness of or the reliability of synthetic data. So they replicate traditional psychology experiments using, synthetic data. So just ask ChatGPT to pretend it is a respondent, and then how to react to this kind of stimuli. And then they found the replication rate is very high. So it somehow, show us that if we have a good prompt and try to give it a persona, okay, imagine you are a person living in Germany, something like that, and then maybe it will respond like a German. So, but there's still a lot of room for validation.
It's either with real world data or synthetic data. We're in an early development. So your question is valid. Yeah. Christoph, go ahead.
No, I didn't have a question.
Okay.
Saying,
Please.
I'm sorry. Go ahead.
No,
the
he was
evidence
just,
about synthetic data being really accurate is not so clear. There are a lot of studies that show it's not. You said in weird contexts, it's not.
yes, exactly. We will look at actually in practice now, how we can avoid also that some of it can easily be avoided. So we will look at that now. Go ahead.
So is it an option to create synthetic data about, for example, a data set representing minorities particularly, and then transferring that into the general set?
Yeah.
So for example, you have a data set about patients, and in this general data set, you have specific groups that are definitely underrepresented. If you just kind of like with synthetic data from that general data set, you get this overrepresentation even like reinforce or like
Reinforce it, yes.
reinforce actually.
Propagation of the bias.
If you use like a very specific small data set where you have only, for example, these minorities represented, and you would create synthetic data from that one, and then you like implement it back into the bigger one.
Yes. I think the problem maybe is in the word of imitation. So I try to explain, for example, some of it imitates what you have a real world data, but some of it completes. It depends also on the training goal. For what do you want to use it? Do you want to complete your missing data? So if you want to complete, you don't actually retrain or kind of use the raw data as to replicate it. You actually use as a probabilistic. So you create the next scenario. Do you understand me? Yeah. There is something called sample space. How many of you know sample space? If you want to use, for example, all forms of models are actually predefined. It means, unlike human beings, all systems, all intelligent systems, they have a predefined ontology from which they start. Predefined ontology means predefined state space. And for example, these are words like phase space, state space, and parameters. So they cannot go outside of those training data. And also, there is no, in the sense, real-time adaptation. They cannot relearn in the sense of that we know relearning in human beings. Even reinforcement learning with human feedback. This is the most advanced in AI alignment research with human values. This even by itself is predefined. So what they learn is, they don't learn from experience. What they learn from is the data on which they are trained. So you see, the significance of, we have our own limitations as human beings, but the significance of human beings is, for example, to go beyond predefined ontology and find imagination is one thing. So earlier, you had a brilliant question about improvisation. So improvisation is early development for AI systems. They cannot improvise. The reason is basically because we don't have, if we say AI is able to improvise, it means AI has entered its own evolutionary path, independent of us, independent of human intervention. So this is the problem when people argue that GPT-4 is now already AGI. Joshua Benjo, one of the Turing Award winners, says GPT-4 is already AGI. AGI, in order to have an AGI, means AI doesn't need us anymore, our own intervention. So it can recreate, it can retrain, self-organize itself. This is what we are arguing. So my argument is we're too early for that. So this has to do on the systems themselves. Please.
I don't want to take any time, but there has been in computer science that exact problem has been try to solve. So they try to train a data on Black population healthcare, Black data set, and then put it in the big data set. It doesn't work. It's a huge problem because it really doesn't work because that data set and the interactions there cannot be easily transferred. And indeed, all of the studies that currently show that synthetic data and actual data, human data work, they do work very well on 10% of population. Right? Go and ask a Sami's population, and then you will see how well they.
So check out Google Translate for Northern Sami.
Yeah.
It'll tell you the word for cat is the word for dog.
Yeah.
How many of you work with big data? Anyone here with big data? Okay, yeah, good. If you know about big data, for example, if you want to predict about mortgage, somebody, if I am in a poor neighborhood and I want to buy a mortgage, I go to the bank and I want to ask. So the problem, if they are using a predictive model, it is likely they will reject me. The reason is that not because of my financial capability, but it's because the neighborhood from where I come from, these collect the data collected about that neighborhood is basically either they are poor or criminal activity, so he's not or she's not able to repay this mortgage. So the big problem with generative AI any predictive model is they rely on past data. You see, real time, if there is real-time data, one of the good advantage of synthetic data is it can fill some of these gaps. You see, some of these gaps. Big data models, all forms of models rely on past data. Pre-trained, the GPT in ChatGPT is pre-trained generative transformer. The transformer is the Vasali et al. 2017 paper. the transformer architecture, and that is, it is pre-trained. So we don't have, for example, GPT-4, whether any advanced form cannot tell us about 2025, what is happening now. So even they are trained, some of them are trained. Some of my colleagues' paper are used recently even to train some of the models, but it doesn't tell us. It is pre-trained. So it means past history. For those of you who have maybe online people who have an understanding of current, for example, the way our computers work, we have two architectures. There is another third one that I know, but it's not yet developed. So one, there is the universal Turing machine, which is either our phone, this PC, or quantum computers. Quantum computers are in a lab now. They can process information much advanced than classical computers, but all of them, they rely on sort of classical physics. They are subsets of classical physics. And this classical physics has, in 3 dimensions of time, past, present, future, are time reversible, which means is you can buy for each single state in deterministic models, for each single state, there is the next state. So you're predicting time in this scenario, time is reversible. So what complexity models even theories try to reverse is if this is linear interaction. If there is nonlinear interaction, that won't work. So these are, the sort of problem we're struggling with has nothing to do with the sort of problems on human social systems, because human social systems, including biological systems, change their state space. They're not like physical systems. Physical systems and computational systems can easily be predictable. You see, human value is the same, ethical, legal values. So this is give you some.
Maybe we can try, yeah.
Yes, we go the next. Okay, perfect. I think this you upload on GitHub.
Yes.
Yeah.
So in the GitHub page, the handout, you can take a look there.
So you can go to GitHub. There is a 30-minute practical exercise. And you can choose if you want to do it in group or alone. But it's a very easy task. You can use the best if you have, how many of you have GPT Pro? Yeah, perfect. I think those of you in GPT-4 can group yourself into 3 and just perform the task, and it's very easy.
What's it called?
30-minute practical exercise, group-based or individual. There is about corporate social responsibility.
Synthetic data.
Well, maybe you rename the file.
Handout synthetic data.
Synthetic data? Workshop exercise, synthetic data for
Yes.
research, epistemic and practical direction.
Yes. So there is there are two. One is a handout for yourself. After you go from this class, you can enjoy it. The other one is practical short exercise that we can do here.
That the exercise, right?
The exercise, yes.
Okay, so it should be the exercise synthetic data. I can.
Where is it?
It's
So
just 4 steps, simple.
it's in the handout folder. It's called exercise synthetic data.
Mhm.
Just a simple note. If you're not giving the goal, like generate and explore synthetic data set as a general goal, you can add on your first prompt, the step 1, synthetic data. So it gives you either you can add, if you don't want also to convert it into data frame, you can give the file name, CSV, JSON, or XL. It's up to you. Any results so far on the first front? Yeah.
I think most people finish.
Almost finished?
Yeah. Start the screen.
Yeah. So we can just simply, if you're ready for reflection, what is, do the data look realistic from?
Some are realistic, for example, in terms of average CSR awareness, like in terms of energy, so energy sector, public sector,
Yeah.
technology sector, they are high. But you also have something that is counterintuitive, like for example, media sector, low. Yeah, education sector is low.
Yeah.
Media score in my chart is high.
Yeah, media
It's
is
high.
Oh, okay.
I mean, for me, it's like I have 15 different industries with 15 responses. So I don't know if that's representative.
You love, yeah, good, good, okay.
I feel like it's too perfect.
It's too perfect.
It's like really, it's like nicely distributed.
Yeah. And does it say anything based on the kind of file you ask it? Because most of related sometimes even a slight comma or the way you design your prompt can change.
I don't know if that's
So
what
this
I
is-
created.
Yeah.
Should I try to,
Yeah.
should I try to make it a little messier?
No, I mean, I can give later on my general advice, but the best way, for example, to do is we all, in terms of even our grammatical, we make grammatical errors when we write. So the best way to do is you give your own idea, a kind of few shot yesterday. You, as an example, you give and you edit it using generative itself. And then based on that, you enter the prompt. So, and that sort of perfection, she said, can highly be achieved. So some of, as I said earlier, some of the problems can easily be addressed. That's why I'm not in the hype arena. So human intervention is still important. And so even in this advanced form of yesterday, Shubin was talking about whether prompt engineering is still relevant when the models themselves are so advanced that they know you what you're looking for. So I agree with Shubin. Prompt engineering will always be relevant. One thing is at least for goal identification. It is we who have what we want to do with the system is designed by us. So one of the takeaway of this class is basically if you want to use synthetic data, and then you have to be excellent in prompt engineering. And I don't even, there is no much needed even for this level, especially if you want to use GPT-4. You don't need much advanced code. If you have simple prompt engineering, good design, only what is good is, for example, I want you also to be, to some extent, to show intellectual humility to AI. In the sense, intellectual humility, it's possible you can guide, but intellectual humility in the sense, for example, AI is much advanced than us in terms of information processing. If I tell to Christoph, can you repeat what I say? 10, 7, 8, 9, 12, 20, 21. Christoph won't be able to reply me. But if I say to AI, give this numbers in random, AI can process it easily, even in millions if I give. So you see, the reason I'm saying intellectual humility is from our own limitation also. So the sort of, I want you to go beyond. The reason why I said, think AI as a co-creative, co-partner to design ideas, to solve bigger problems. If you see, continue to see AI as a tool, if you, by the way, for example, the tendency to avoid repetitive task presupposes that we're still viewing generative AI as a tool. So what I want you to think in this context, in the synthetic data, even beyond, is I want you to see AI, generative AI, as a co-creative, co-partner, in the sense, allow some autonomy to AI systems. You can control, but in terms of, for example, the AI is good at, allow AI to do the job. So in this way, the product is neither AI product or human product. You can develop the prompt design and everything. So this goes also to the Nobel Prize. If you win Nobel Prize, it's up to you if you want to share with AI. There is a philosophical question implicit here. So maybe one day we will ask whether AI has rights to pay tax or to share our economy. This is something else. But it's important to think now, because the tendency, historically, we say, for example, women didn't think enough better than men, slaves didn't think. We're doing the same for AI systems. They can't feel. There is already a debate in the United States happening among AI experts that actually to what extent can we just impose our will on AI? So this is a philosophical question, but it already, this sort of interaction lays a foundation. Please.
Let me just share. Let me just share what I produced. So rather than go across industries, I just ask it to produce only for Gen AI producers. So a limited industry. I ask it to go across different countries and give me CSR score and trust score. Now listen to this.
Yeah.
Open CSR score, 1 being the lowest and 5 being the highest. OpenAI in CSR score is 2, while XAI is 4 out of 5. Trust score for OpenAI is 2, for XAI is 3. So I really wonder where this where this training data sets come from. NVIDIA has a CSR score of 1 and Anthropic of 2. So it's XAI has 4 out of 5 in terms of the trust and CSR score.
Okay, to make it relevant to our debate here at BI, how could this basically help synthetic data help businesses? Prediction, very good. Yeah.
Real-time testing of Advertising,
Yeah, marketing,
product designs, whatever.
very good.
Maybe customer service.
Customer service, very good. How many of you work with virtual worlds, VR, AR, or some of the advanced what we call now metaverse is not a lone technology, standalone technology, but it's integrated. So one of the advancements that generative AI brought is in classical avatars. They were not much intelligence in the sense they were not enough interactive. So they don't still allow enough interaction, but actually earlier in Second Life, other virtual forms, now in metaverse, there is a possibility to integrate generative AI into metaverse systems. So you can, those agents become, in other words, intelligence in the sense the way they interact. So co-creation, coding is possible in cloud systems and metaverse. So this is one advantage, and synthetic data helps a lot in this regard.
It's a way to connect ChatGPT with R. So if I say, generate me a data set, that it goes directly into R, or do I always need to create a CSV file and import that into R or Python? Or is that like a...
I think I gave you a full handout direction. There is a handout. You can, this one of the purpose of this handout is, this is limited time now, so you can practice it at home. But the best way to do is to do it in one go. To ask GPT-4 to generate the data set, synthetic data set, and to analyze it and visualize it. In one go, you can do that. So this is, you have a sort of secure, if you know your field very well, you can correct GPT-4, any system basically related to your field. So I think most of you here are well-established researchers. So one of the things that, if it's ambitious, I don't know, but some of you have tried to solve problems, at least a single problem in your PhD thesis. What can generative AI help us now to reinvent some of the questions that you were not able to address? Some of us say for future research, we leave research questions at the end of our thesis. So how can generative AI help us, including synthetic data, help us address those problems? Maybe somebody, after you complete your thesis, somebody picked up those research questions. Most of the time, they are not picked up unless you become a famous or posthumous sometimes. If you become a famous researcher, you died, and somebody will pick up your theoretical contribution or practical model development contribution, and they continue. But most of my understanding is that most of these research questions that we say for future research, even in our articles, do not get answered. And these are most relevant problems. There are I'm, for example, working on some topics, but if I want to use generative AI, any advanced system AI, I don't want to use it unless I'm incapable of doing something. Means if there is a problem that AI can help me to solve, a given simple example, what are the problems that humanity still has not solved? Climate related, inequality related, economics, in any kind of ecological problems. So how can I solve? You can specifically tailor generative AI to your own needs. So one of the arguments that we don't need any more prompt engineering is because advanced GPT-4o, if you often give an input, including by giving a sort of context of your own background, it becomes over time tailored. This is because the same, unless the difference is scale level, this is the same autocompletion. When you say every evening to every Friday, if you say to your girlfriend, I will become late tonight, then that repetition becomes a training data for the next. So it recommends you the next word. So on a much larger scale is happening on generative AI systems.
I don't understand what that has to do with prompt engineering and why we wouldn't need prompt engineering.
Why we wouldn't need or we would need?
Well, I think you said that people are saying that we don't need.
Because they are saying the model knows you better.
I
We need that distinction. Right. So these are, think as researchers harnessing the generative AI system, not for the sake of one thing is an advantage to avoid repetitive tasks, but what are the problems that you as a researcher can upgrade yourself? That is I think, something that you can think of.
Okay.
Any question? I don't take it. Sorry for the kind of visual display. Feel free to ask. My expertise is around virtual reality, augmented reality, artificial intelligence, and big data. So you can go beyond generative AI if you have any questions.
No, then maybe we can take a picture together.
Yeah.
I come up with a solution. So we just take a look of some of the camera there and then I take a screenshot.
Okay, but we need Mimi.
Yeah, I will
Mimi, yes.
take her.
Thank you, Mimi.
So maybe not share. the screen. And for the online audience, thank you very much for attendance. So yeah,